humans, I'm Mr. Khing. Hello, welcome back to my channel, boys and girls. So now, let's go into this past year paper, May-June 2022, paper 43. Let's get started. So you see, given with this, so which one is a product of respiration? See, respiration, we breathe out carbon dioxide gas. Now, which one is a main constituent of hematite? Remember, hematite is iron trioxide. Elements which has a sulfate that is used to test for water. Remember, you see, we test H2O using anhydrous copper 2 sulfate. So, copper. Colorless toxic gas, carbon monoxide. Reactant in fermentation, we use glucose. Reducing agent to extract iron, it is carbon monoxide. Conductors of electricity in solid, so it has to be metals, copper. 21% in the air, oxygen. Okay, Q2, I see, given with this element symbol, so you see, you are asked to answer in terms of proton, neutrons, and electrons. So how isotopes are the same and different? Remember, isotopes, they are the same because they have the same numbers of protons and electrons. They are different because of the different numbers of neutrons. So next one. So explain why each of these isotopes have an overall charge of 0. You see, remember why isotopes or atoms are neutral again. Okay, they are neutral because they have the same numbers of protons and electrons. So same numbers of protons, electrons, they cancel the charge of one another. So next one, why they have the same chemical properties? Okay, whenever you see this, isn't it? Answer it is always the same. Okay, elements that have the same chemical properties because of having the same numbers of electrons at the outermost electron shell. So same numbers of electrons keywords and outermost electron shell keywords. Alright, so these two are the keywords. Okay, next, see, explain. So why sulfide ions have a charge of 2 negative? So you see, why is it 2 negative? Yeah, why it is not like -1 or -3? Why it is 2 negative? So remember, in this case, you need to be very specific with the answer. Okay, like why it is 2 negative? Because it has 2 extra electrons than proton. Okay, you need to compare the numbers between the protons and electrons. So next one. So remember, you see, what is anions? Remember, anions is negative ions. So what is the negative ions that have the same electronic structures as S2 negative? See, remember, electronic structures means electron arrangement. See, S2 negative is 2,8. So what is the negative ions with also 2,8? Okay, so answer is Cl negative or P3 negative, like Y. See, Cl initially is 287. Okay, sorry, S2 negative is 288, my bad. Okay, so you see 287. So it gains 1 to form 288 Cl negative. And then P initially is 285. So it gains 3 to 8 what? So become 288. P3 negative, you see? 288, 288, 288. Yes, so this is the reason why answer is Cl negative 1 and P3 negative. So next, okay, cation ions. Yeah, positive ions. So what's the positive ions with the same electronic structures as S2 negative? So answer will be K plus or calcium ions. Okay, so how do we know? You see, potassium right initially is what? 2881. Donates 1 become 288 K positive. Okay, and then calcium initially is 2882. Donate 2 become 288. Become Ca2 plus. So you see, 288, 288. Okay, then next one, given with this. So what types of bonding present in the atoms of nitrogen molecule? See, nitrogen molecule is what? So it will be covalent. Okay, non-metals. Okay, they form covalent bond. So you see, you're asked to answer in terms of what? Attractive forces between particles. Okay, why nitrogen? It has a low melting point. Okay, I see. Because of the weak, so what is covalent bond called again? Intermolecular forces of attraction. Okay, between what I see. What are the particles present in covalent compound? It is molecule. Why nitrogen does not conduct electricity? You see, non-metals what? Okay, there is no free moving ions or electrons. It doesn't contain any of this. So this is the reason why, okay, non-metals, they cannot conduct electricity. Okay, next given here, you see this is about what? Haber process. See, you are asked to give the essential condition together with the chemical equation. So, temperature 450 degrees Celsius, pressure 200 atm, catalyst iron. Okay, followed by chemical equation. See, to produce ammonia, see, nitrogen reacts with hydrogen. And please remember this. This is an example of reversible reaction to produce ammonia. Balance equation 2, 3. That's it. Next one, given with this, I see balancing equation. Okay, so how to balance this? You see, we know that we cannot change the numbers from this one. See how many Cl here? 2 Cl. To make it to 2. Yeah, so in terms of Cl balance, now left hand side there are how many nitrogen? 2 multiply with 1 you get 2. To make it 2 nitrogen, 2. Okay, left hand side there are how many oxygen? 2 multiply with 1 multiply with 2 you get 2. To make it 2, we put 2. That's it. So this is how you balance this equation. Okay, then next one, I see drawings of covalent bond. So how do we know? Okay, like how to draw it? Okay, how do we know how many electrons for sharing? So first look for the electron arrangement. See, hydrogen is 1, nitrogen is 2, 5. So you see, from 1 to 2, how many more you need? You need 1 more. So therefore, hydrogen, it can only share 1. From 5 to 8, how many more you need? 3 more. So therefore, it can only share 3. So eventually, see, hydrogen share 1, 1. Remember, dot and cross matter, yeah? So hydrogen cross, so nitrogen will be dot. So it should share 1, 2, 3. See, share 3. Okay, it's 5 valence, so you share 3. How many more left unshare? 2 more outside. So you see, if this nitrogen is dot, so the next one, it has to be cross. So share 1, 2, 3. 2 more outside. Hydrogen share 1, 1. That's it. Okay. Next one. Okay, what is meant by the term base again? Okay, so you see, what is the meaning of base? Remember, base, it is also called proton acceptor. Okay, so next one you see, you are asked to write a chemical equation for the reaction between 1 molecules of hydrazine, okay, and 1 molecules of water. Okay, hydrazine and water. So you see, if you notice, right, you see example is given here. See, it's mentioned here. Ammonia and hydrazine, they are both base. Even though the base, they are proton acceptor. So you see, if you look at here, you see proton acceptor means they gains hydrogen. So you see, NH3, it gains 1 hydrogen ions to form NH4 positive. Okay, and H2O, it loses hydrogen to form OH negative. You see, basically, example is given to you over here. Okay, so you can refer to this example and easily get the answer. See, like how it looks like. So, N2H4, it reacts with H2O. So you see, it gains hydrogen, so to become what? Okay, N2H5. So it gains 1 hydrogen, become positive 1. And then H2O give away 1 hydrogen to form OH negative. Oh, so sorry. Okay, the chemical symbol is reversible. Yeah, you can take this as example. Okay, so this is how it looks like. Okay, next one. What is meant by the term catalyst? 2 marks. Let me see, catalyst means substance that speed up rate of reaction and remains unchanged. Okay, how do you get 2 marks? Speed up rate of reaction 1 mark, remains unchanged 1 mark. Okay, next one, I see. Complete the table, you see, in terms of what? In terms of the rate of reaction and also the positions of equilibrium yield of the products. Okay, so first you see, look at the rate of reaction. So what will happen when the temperature increases? Okay, we know that when temperature increases, it will always speed up the rate of reaction. So rate of reaction increases. Yeah, next one, how about decreasing the pressure? So remember, see, when the pressure decreases, okay, it decreases the concentration. So when the concentration decreases, the rate of reaction decreases. Okay, next one, effects on the equilibrium yield. So you see first, how temperature affects the position again. Remember, increase in temperature favors endothermic reaction. So you see, clue it is given to you here. Forward reaction exothermic. So it means that forward exo, backward endo. Yeah, so you see, we know that increase in temperature favors endothermic reaction. And in this case, endothermic reaction is backward reaction. So which means position, it will shift to the left. So when position shift to the left, so what would happen to the use of the products? You see, products, it turns back into reactants. So therefore, it decreases. Okay, next one, how about decreasing the pressure? So remember, when the pressure decreases, it favors the side with higher moles. Okay, so which side with greater moles? So we check. So you see left hand side, 1 plus 1, you have 2. Right hand side, 1. So which side with greater moles? 2 is greater than 1. You see 2 is on the left hand side. So same thing, position is shift to the left. So when position shift to the left, the yield decreases. Okay, so next one, okay, given with this alcohol, so what is the general formulas of alcohol again? CnH2n plus 1 OH. Okay, so next one, general characteristics. You see, other than having the same general formula, what else? They also have the same functional group. Okay, and they also have the same chemical properties. Alright. Okay, then next page, given this, you see, one alcohol containing 3 carbons, is called propan or propane 1O. So draw the structures of another alcohol containing the same numbers of carbon. You see, basically they are asking for what? Isomers. Okay, so how do we draw the isomers of alcohol? Basically, it's just based on the different positions of OH. Remember, see, propane 1O means the OH is attached to the first carbon. So another isomer, it will be OH attached to another carbon. See this one, OH attached to second carbon, so therefore it is called propane 2O. Okay. Next one, so how to name the ester again? So you see, first we locate the COO functional group. Remember, you see, hydrocarbon that's attached after the O in COO, it belongs to the alcohol. Okay, and then another side, it is all acid. So how to name this ester? See, alcohol how many carbon? 1, 2, 2 carbon. Okay, acid how many carbon? 1, 2, 3, 4, 4 carbon. Alright, so name the alcohol and carboxylic acid needed to produce this ester. See, alcohol how many carbon? 2 carbon what? Ethanol. Acid part, butanoic acid. Okay, next one. How to look for empirical formula again? Okay, so first we need to draw a table. You see 3 marks what? Okay, you need to draw a table, label all your steps nicely. So carbon, hydrogen, oxygen. Given to your percentage, we look for the moles, and lastly look for the ratio. So given 58.82, 9.8, 31.37. So look for the moles, divide by the MR. So eventually you would obtain 4.9, 9.8, 1.96. Okay, ratio divided by the smallest number, so which is 1.96. So on the number, divide by that. You get 1, you get 2.5, you get 5. So remember, you cannot simply round off the number. So we can turn the decimal to whole number by what? Okay, remember, always start multiplying by 2, 3, 4, 5, and so on. So 2.5 to whole number, we can do it by multiplying 2. So eventually you get 5, 10, and 2. So answer is C5H10O2. Okay, easy 3 marks. Next one, see, given this empirical formula, okay, with relative molecular mass 116. So how to look for the molecular formula? Or how do we turn the empirical formula into molecular formula again? Okay, we need to look for the factors that we have to multiply into the empirical formula, okay, to get the molecular formulas with a mass of 116. Okay, so 3 carbon, 12 multiplied by 3, you get 36 plus 6 plus 16. So eventually you get 58. So n equals to 116 by 58, you get 2. So you see n equals to 2. So you multiply 2 inside, eventually you get C6H12O2. Alright, so this is how to look for the molecular formula. Okay, next one, I see copper. Okay, metals. You are asked to describe the bonding in metallic elements. You see, what is the bonds in metals again? Remember, it is also called metallic bonding. So how metallic bonding looks like? So you see first, draw, so let me see, they arrange closely packed to one another. Okay, minimum 3 by 3. Okay, copper what? So they form what? Copper ion, CO2 plus. Yeah, and there are also electrons or so-called sea of electrons surrounding all the positive ions. So this is how the metallic structure looks like. Okay, and how do we define the term of metallic bonding? Okay, it is electrostatic forces of attraction between positive ions in giant lattice structures. Okay, and sea of electrons. So keywords are electrostatic forces of attraction, positive ions, and sea of electrons. Okay, next, I see electroplating. So you see, when it comes into electroplating, isn't it? Okay, so you see given here, metal spoon. Okay, with copper. So what is anode? So in this case, anode means the anode it is always the metals they want to plate on the object. Cathode it is always the objects to be plated. So electrolyte wise, you see you're using copper. So electrolyte it has to be copper solution. So you can use equals copper to nitrate. Always use nitrate. Why? Because all nitrate, okay, they are soluble salt. Next one, see given with this, okay, moles calculation. So first, you see, you're asked to look for the numbers of moles of acid. You see, given what? Volume and concentration. Okay, so formula N equals to CV. Concentration 0.2, volume. Let me see. The unit for volume is always in dm3. cm3 to dm3, we divide by 1,000. What do you get? 0.05. Yeah, so eventually we get 0.01 mole. Okay, next one. So what is the numbers of moles of this hydrated copper 2 sulfate? Okay, that's formed. Remember, compare the ratio. See, H2SO4, we found that it is 0.01 mole. And compare ratio, so what's the ratio? 1 to 1, isn't it? See, same ratio, so the moles of this, it will also be 0.01 mole. Next one, you see, you are given with the MR. Okay, the molar mass 250. So what's the maximum mass? So when they ask for maximum mass, isn't it? It means that they're asking for the M. So 0.01 equals to M divided by the MR 250. So eventually M equals 2.5 grams. Alright, so this is how you solve this calculation. Okay, then next one, given me this. So what is the observation that would indicate that the copper 2 oxide is in excess? So how do we know it is in excess? Yeah, so how do we know? Yeah, so copper 2 oxide what? So when it is in excess, the solid, it will stop dissolving. Okay, solid stops dissolving. Next one, I see. It's mentioned here, step 1 is repeated without heating the acid. So all other conditions they are kept the same. Rate of reaction decreases. So give a reason why the rate of reaction decreases. You see why it decreases. So you see, without heating, isn't it? So eventually, what will happen to the kinetic energy? Okay, so kinetic energy of particles decreases. So which eventually particle moves slower. So when they move slower, frequencies of collision decreases, and which eventually lesser particles that have sufficient energy to react. So therefore, rate of reaction decreases. Okay. So next one, you see, other than copper 2 sulfate, what else can be added? Okay, to react with acid to form copper 2 sulfate. Okay, so remember, answer, it can only be copper 2 hydroxide or copper 2 carbonate. See, in this case here, you cannot put you cannot put copper, because copper cannot react with the acid. Copper is less reactive than the hydrogen. There won't be any reaction. Okay, and then what's the process that can be used to remove the excess solid from the solution? So it is filtration. Okay, next one. Suggest what is meant by the term saturated solution. See, saturated means solution that cannot dissolve any more solute at that given temperature. So how to get 2 marks? Cannot dissolve any more solute, 1 mark. At that given temperature, 1 mark. So this is, I'll get 2 marks. Okay, next one you see, given here. The phrase heating to dryness, it means heating until no more water is given off. So explain why aqueous copper 2 sulfate is not heated to dryness in step 3. So you see, what is step 3? See, step 3, we carry out crystallization to obtain the crystal. Remember, you see, crystal, they are hydrated compound, contains H2O. Okay, so if you heat to dryness, isn't it? Okay, it will form anhydrous copper 2 sulfate. Okay, which is not crystal anymore. You see, crystals are hydrated compound. Without H2O, it is not crystal anymore. Without hydrated, it is not crystal anymore. So answer, it would form anhydrous copper 2 sulfate. Okay. Remember, yeah, all crystals, they are hydrated compound. Okay. Next one. See, given to you periodic tables. So you see, describe 2 other differences in the chemical properties between group 1 and transition elements. Remember, transition elements that forms colored compound. What else? Transition elements that can act as catalyst, but group 1 cannot. Okay. What else? Okay, transition elements that have more than 1 oxidation states. So you see, any of these, the differences in terms of chemical properties. So you see, they asking for observation. See, when group 1 elements potassium is added to cold water, and you are asked to also include a balanced chemical equation for the reaction and include the state symbol. So you see, when potassium is added, isn't it? You see, remember, group 1 metals react with H2O to form metal hydroxide and hydrogen gas. So when hydrogen gas is produced, so what is the observation? Okay, bubbles form, fizzing. What else? Okay, the potassium, it will react, isn't it? So potassium solid, it dissolves. What else? Remember, group 1, they are highly reactive. Group 1 elements come in contact with H2O. It is explosive. Okay, you can say, explosion happens or flame is produced. Okay, any, okay, like 3, okay, 5 marks what? Okay, and then followed by equation, potassium solid, it is added into H2O liquid to form metal hydroxide, potassium hydroxide solution equals plus hydrogen gas. So is this a balanced chemical equation? It is not. 2, 2, 2. That's it. Okay. And then, okay, next one, I say differences, okay, in terms of physical property between group 1, okay, with transition elements. See, other than transition being stronger, what else? Okay, transition elements that has higher density. Transition elements that has higher melting and boiling points. Next one, I see. Displacement reactions of halogen. Okay, so you see, describe the color change of the solution. So you see, what is the colors of potassium iodide? So how do we know what is the colors of this ionic compound? Remember, for the color, isn't it? Okay, for the colors of ionic compound, we look at the metal ions that are present. So you see, potassium. Potassium non-transition elements. Okay, means in non-transition elements, in the forms of solution, they are colorless. Okay, and this reaction produces what? Iodine. See, when iodine is produced in the solution it turns brown in color. Okay, iodine liquid is brown in color. So what is the general term given, okay, to the types of reaction in which electrons are transferred from one species to another? So you see, one loses electrons and another one gains electrons. So what is this reaction called? It is called redox reaction, isn't it? Transfers of electrons. Okay, one gives away electrons, and another one gains electrons. So identify the oxidizing agent. Let me see. Oxidizing agent are those that undergoes reduction. So what happens during reduction again? Reduction happens when the substance lose oxygen, gains electrons, or decrease in oxidation number. Okay, so which one? So you see, which one gains electrons? Okay, you see this one, electrons is written on the left hand side, isn't it? See, it gains electrons. So answer is bromine, Br2. Okay, bromine, Br2. Why? Because it is reduced by gaining electrons. Okay, it undergoes reduction by gaining electrons. Okay, next one, how you see? Reactivity. Okay, displacement reaction. Remember, you see, the one that's more reactive would displace the one that's less reactive. So what's the reactivity in group 7 again? See, how to remember group 7? Father called brother's idiot. Again, group 7. From top to the bottom, it gets less reactive. See, can Cl displace Br? See, Cl is more reactive than both Br and I. Okay, so Cl can displace both, so therefore there are reaction. See, Br less reactive than Cl, no reaction. Iodine less reactive than Cl and Br, so no reaction. Alright, okay, so that's all for this paper. Alright, thanks. Remember to like the video and subscribe to the channel. See you again. Bye.